Good day everyone. For our project, we developed a Java application titled Knight's Tour Java application. This was created to stimulate the classic chess puzzle known as the Knight's Tour. In this puzzle, the goal is for a knight to move around a chessboard and visit every square exactly once, following only valid knight movements, moving in an L shape, 2 squares in one direction and 1 square in a perpendicular direction. The challenge is not only solving the tour but also handling user interaction visual feedback and enforcing chess movement rules in a Java GUI environment. We also concluded several added features like score tracking, board size, selection, restart, functionality, and valid move highlighting to enhance user experience and engagement. Okay, so let's start off with the method. To build this project, we used Java Swing for the graphical user interface and basic data structures to manage game state. Our development process followed these steps: board initialization. We used JButton component inside a grid layout to dynamically generate a board ranging from 3x3 to 8x8 as selected by the user. Next is user control. The knight's starting position is selected by the first click. All following moves must be legal knight moves. And for our move validation, we check for valid L-shaped moves using this logic. So moving on with the tracking moves, a 2D Boolean array tracks visited squares. The number of moves is counted and displayed as the score. And lastly, game state. The program checks for victory. Victory which is visited by all squares, or a stalemate if there are no legal moves left. So for the extras, there is a reset button, allows users to change board size at any time.
Okay, now I'll walk you through each stage of how the Night Store application works from start to finish. So when the application is launched, a pop-up message box appears, read as Night Store by Lim and Ramirez, so it ensures the user knows the application is ready and who created it. It also serves as a welcome screen and a branding element. Now next is the board size selection, so difficulty setting. After the welcome message, the user is prompted with another dialog box. So the dialog box asks for select board size and shows options like 3x3, 4x4 until 8x8. So this allows users to customize the difficulty level. And disclaimer, 3x3 and 4x4 are harder or mathematically unsolvable for full night tours. Now let's choose a size. The selected size is stored and the board is drawn accordingly. Make it bigger so the change difficulty option can be seen. So based on the selected size, a new grid layout is created using Java Swing's grid layout. So each square on the board is represented by a J button. The buttons are styled in alternating white and light gray like a chessboard. The application creates a clickable visual chessboard in the center of the screen. Now, so placing the knight, our first move. The user clicks any square to place the knight, for example here. Now, this square becomes the knight's starting position, so a knight symbol appears on the square to show it is active. Now the score counter immediately starts at 1, making the first move. So below here, you can see the score. So next, another feature is that the valid knight moves are highlighted. So as soon as the knight is placed, the application calculates all legal knight moves from its current position. These possible moves follow the L-shape rule. So 2 squares in one direction and 1 square in the perpendicular direction. Any valid destination buttons are highlighted in soft blue to visually guide the player. This makes it easier for users to understand the knight's legal movement pattern without guessing. Now, for example, the user continues clicking squares. So if they click square is a valid knight move, it increments the score, displays the next move number, and highlights the knight's new position with a knight icon, and colors the previously visited square yellow. It also recalculates and highlights the new set of legal moves. Now, once the user clicks an invalid square, a warning message appears. Invalid move, knight moves in an L shape. Next is the score tracking and completion message. So each move increases the score counter. If the knight has no valid moves and wait, let's finish this one first. So if the knight has no valid moves left and some squares remain unvisited, it shows no more valid moves, your score, and then your highest score. In both cases, the highest score is updated and displayed in the bottom panel. Now, if once you complete or beat the game, there's also a prompt where it says you completed the night's tour. But I cannot do that right now because I'm not that very good in playing this game. Now, the user can also change the difficulty once. So, once click, it resets the board and it allows the user to start a fresh game with new difficulty setting. Now, there's also a on the move feature. Now, the user ends up with a full interactive game board where they control the knight step by step and they learn valid knight movements through real gameplay. They get feedback from colors, symbols, and messages. They can also replay with different board sizes for more challenges or to practice. So the difficulties in making the code. So we came with several challenges. First is the movement validation. At first, we tried allowing nearby moves, but we realized that the knight cannot move to adjacent squares. It only moves in L shapes. We had to rewrite the logic to strictly follow chess rules. Next is for tracking game state. So ensuring the knight didn't revisit any square, updating the scores correctly, and knowing when the game should end required careful condition checks, and array tracking. Next is for the interface handling, syncing the GUI updates with the logic like showing the knight's position, highlighting moves, and updating buttons was more complex than expected. Small bugs in indexing could cause major display issues. Next is edge cases. We also had to handle issues like when users cancel dialogues, select impossible board sizes like 3x3 or 4x4, or try clicking on visited tiles. Lastly is the visual feedback. Creating clear visual cues for visited squares, current knight location, and next legal moves took experimentation with colors and fonts.
To conclude this project, this gave us a chance to explore the intersection of game logic, user interaction, and GUI design. It taught us how a simple chess rule can lead to deep logic challenges, especially when involving real user input. Our final project is a working and interactive Knight's Tour simulator, featuring manual control, score tracking, valid move highlighting, with user-selected board sizes and visual feedback. We also learned how to use Java Swing effectively for layout and event-driven programming. If expanded further, we could add an automatic solver for generating full night tours, animation for moves, sound effects, or accessibility improvements. Still, as it stands, the application serves as a complete and educational tool for understanding night movement and logical constraints in programming.